Hey folks, Professor Gray here, ready to talk to you more about two-sample hypothesis test. As mentioned in an early video, there are three types of hypothesis tests that involve two samples of independent data. We've talked about the two-sample proportion test. Now let's talk about the two-sample z-test. Two-sample z-test are tests involving two means. Here's some notation. Mu sub 1 is the population 1 mean. Sigma sub 1 is the population 1 standard deviation. N sub 1 is the sample size of the first sample. X bar sub 1 is the sample 1 mean, and S sub 1 is the sample 1 standard deviation. Of course, corresponding notation applies to population 2 and sample 2, so I would have a sub 2 for those symbols instead of sub 1. For a hypothesis test involving two means where sigma, that's the population standard deviation, is known, we use a two-sample z-test. This uses a normal distribution, thus the use of the z, and the test statistic that's shown on this slide. For the most part, we will not use this formula. We'll use the calculator command two-samp-z-test in the Stat and Test menu. So let's do an example. Do men have a higher mean body temperature? We use the data below with a 10% significance level to test the claim that men have a higher mean body temperature than women. Notice in this problem I have two samples. One's of men, one's of women. And I have the population standard deviation for both samples. This allows me to use a two-sample z-test. So the first step of this hypothesis test is to determine the type of test used. As mentioned, that's a two-sample z-test. The next step is to set up the hypotheses. I'll have the null hypothesis and the alternative. The null hypothesis uses an equal sign. We'll let the men be the sub 1s. We'll let the women be the sub 2s. So the null hypothesis is that mu sub 1 is equal to mu sub 2, or that the mean body temperatures are the same. Use the same symbols for the alternative hypothesis. And for the inequality, I have a greater than, that the male mean body temperature is greater than the female mean body temperature. This is also the claim, so I'll label it. For the next step, I'll find the p-value. I can use the calculator to do that. Under Stat, Test, and two-sample z-test, I have some information to put in. Now, if I have two lists of data, I would select the input option Data. In this particular problem, I have summary statistics for both samples, so I go to Stats. On the next to last line, just as before, I'll match up the symbol, the inequality in H sub 1, the alternative hypothesis, with what's in the calculator. highlight it and press Enter to select it. Now the calculator knows that I'm testing to see if mu sub 1 is greater than mu sub 2. When I calculate, the z-score, which is the test statistic, is given. The p-value is underneath. We'll round that to 4 places. So the p-value is approximately 0.1972. For the next step, I'll compare this p-value to the significance level and make a decision about the null hypothesis. The significance level in this problem is 0.10. That's alpha. Feel free to add extra zeros to alpha if that helps you compare. If I compare that to the p-value, I can see that the p-value is larger. So as a result, we failed to reject the null hypothesis. The last step is to interpret these results in terms of the original context, the claim that the male mean body temperature is greater than that of the females. Because we failed to reject the null and the claim was the alternative, we would say there's not enough evidence to support the claim that men have a higher mean body temperature than women. That concludes this hypothesis test.